Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest today is Vitor Santo, the senior scientist at Just for All. The website is justforall.com, and we're going to be talking about the alt protein revolution. So, Vitor, how you doing?
I'm doing great. How are you doing? Thanks for having me.
Yeah. So, tell me about Just for All. What's the premise of the company, and what do you guys do?
So here in our company at Just, we are a food company that is basically, and our mission is to implement a more sustainable food system where everybody eats well. So, and for that, we have been leveraging our plant-based protein platform and releasing a series of products along the past years in order to achieve this mission when everybody eats well. And for that, the goal is really to release affordable products that are highly nutritious, and for that, that's
okay,
part of the
good.
mission. Yeah.
Well, I mean, food is, there's tons of different kinds of foods. I'm sure you guys have your focus. What kind of food or foods are you focusing on?
Yeah. So our first product, we started up with our mayo, and we have been releasing additional products along the way. So we have also our cookie dough. And right now we have two big products that we are working on. So our big release is Just Egg, and also in the near future, our clean meat products. So these are some examples of the products that we have been working on. And for those, basically what we have done is used our internal technology, our plant-based discovery platform, to leverage which proteins extracted from plants could be used to achieve this kind of great food functionalities and great cooking experiences, and to produce these products that taste really good and that could be produced in a much more sustainable way. So that's really the whole plan and kind of the mission that drives our company. And now we're also extending it for our clean meat program, which is the program that I'm more directly involved, and in which the approach is slightly different. In that case, we're using animal cells, but we're also using our plant-based proteins to feed them. Mm-hmm. So we're still using our discovery platform as part of the strategy.
All right, so you're focused on the clean meat arena. So when you say clean meat, does that mean chicken, beef, and are these just your typical veggie burgers, or like you said, you're using actual animal cells to create an animal-like real burger grown in the lab?
Yeah, so in this case, the clean meat, it's a product that is made from animal cells, not from live animals, right? And in this case, we are working with a bunch of different species, and we're really diversifying our platform. And in this case, we're using our plant-based proteins to feed these animal cells. So basically how it works is that you can collect a small biopsy of cells from different animals, and then you take these cells to the lab, and you just have to feed them with this liquid solution that contains all the nutrients that the cells need to grow fast, sort of like mimicking what happens in the animal body. And for that, we have been really targeting and the knowledge that we have gathered for the past 7 years in all the characterization that we perform in our plant-based proteins. And we are using them to replace some of the most commonly used supplements to feed these cells that as they have several drawbacks nowadays. They are from animal-derived sources. They involve some ethical concerns as well in terms of, because one of them is, for instance, the animal-derived fetal bovine serum. And also they are very expensive, so it would never be able for us to release an affordable product. So that's why the replacement of these animal proteins to feed the cells is such an important step for us, and it will make us a much more sustainable and affordable platform.
So you are going to use animal cells. When you say animal cells, what do you mean? Muscle cells, fat cells? I mean, it depends on the meat, but it's not just made of one. I mean, so far as I know, I don't just eat a muscle burger with no fat in it, or even chicken. The fat's like an essential component of taste, texture, and all that. And there's also structure to the meat. You get a steak. So how are you addressing those kinds of things?
Yeah. So our approach is to do that stepwise. So the first, as you mentioned, really the meat, the muscle tissue is composed by a lot of different cell types. And we're in the process of optimizing the scale-up production of all these different cells. So really the first step is to make sure that we can scale up the production in an affordable way. And then you can mix it up at different percentages, these different cells, like muscle cells, fat cells, cells from connective tissue. You also have blood cells. So it's really a work in progress. But we also believe that this has to be done at different stages. So the first line of products will be something that will be more simple and will be mostly in the texture and complexity of a cell paste. Because what we do currently is we grow the cells in bioreactors, and what you get out of those bioreactors is actually these bioreactors have the cells growing inside in this liquid solution, and then what you get is this cell paste, and that enables you to prepare something like a ground-based product. Imagine something like a sausage or a nugget, right? And this is really the first line of products that we can expect, and you can do that for different species as well. And then down the line, we're still optimizing this process. We can definitely increase the complexity and the type of products that we can release, and looking more at the structural elements you were mentioning and the different combinations of cell types. So that's definitely, we are definitely looking into that. Yeah.
Even to make a hamburger from ground beef, though, I mean, if there's just zero fat in it, I don't know if it would. I mean, I don't know. I'm guessing, but I don't know if it would taste very good. I don't know if it would cook easily. Have you guys actually made some, and have you fried them up and tried to eat them and see what they taste like?
Yeah, we had some internal tasting sessions with the cells that we are producing, and you would be very, very surprised. I mean, especially in the first one that we tried, it's really amazing how we can really identify the species that we are working with. Even in a blinded test, you can really tell from which species you are tasting. So it's really amazing how the cells can really capture that innate flavor. And that's a very important thing that we have also adjusted. We're not just a team of scientists that are working together to make this happen. We also have in-house a great team of chefs. So we give these cells very early on in the process to our chefs, and they cook the cells, and they give us feedback in terms of flavor and texture, or what can we improve, or the combinations you were mentioning before. And this is very important for us to have very early on in the stage, in the process, and it's in-house. And it's a sort of a strategy that we have that has been very successful for us for all our previous releases that we have in the market right now. So it's a critical factor also in the clean meat program.
So tell me what you tasted and what was it like? Tell me your experience.
Yeah, I cannot really reveal the species yet because that will be revealed soon in our first commercial release. But I can tell you that in terms of taste, it really felt like, for me, it was really a sense of mission. I wouldn't say mission accomplished because we still have a long way to go, obviously. But it was really exciting to really feel that we're headed in the right direction. And I could really sense the meaty feeling, like the umami. That's the term that is usually described for the kind of savory taste that you get from meat. And you could really sense that even in really simple formulations. So, and that was the most exciting part of it. It was that it was really unique and something that I could never sense it in, for instance, in alternative plant-based products. So I really think that for me at least that was very important to sort of clarify the need and for a product like this. I think this will have a great market and people will be able to sense the difference. And I think once we get the first line of products out, I think this will be very important.
Yeah. So the meat you're currently making, again, are you separately culturing fat cells and then just mixing the two together, the muscle and the fat, to make it more realistic, or is there a difficulty in culturing, more than one kind of cell?
Co-culturing, yeah, the establishment of co-cultures is definitely more challenging, and it involves, in terms of media optimization, so the protein composition that you have to select to feed both cell types, it's definitely a more challenging step, and we're working on that. At this stage, I would say that it's easier to culture cells independently. And then produce the mixtures later on in the process. Like it's product development stage, then you can just make those mixtures. But I also believe that once you have an optimized media formulation, that you are able to co-culture both cells simultaneously. I believe there might be some advantages in that as well. But again, this is a work in progress. I think we'll still have it's a learning curve for us.
And the species of animal cells that you're culturing, from what I've read, the particular cows that we eat, they were chosen not necessarily for their best taste, but they're chosen because they get huge really fast and they respond to the current methods by which we raise them. So is there a wider range of portfolio of animals that you could use to culture their cells, or are you sticking with the current ones that we tend to eat in restaurants and stuff?
Yeah, so I think that's one of the beauties of this process is you can actually implement the platform not only for different species, but also within the species, as you were mentioning, you can choose different types of animals. And we're definitely looking at that for from more standard, let's say, types of meats, more conventional to more premium types. And I think this is because once you have the platform established, that starts from cell isolation up to scaling up to in an optimized bioprocess into a pilot plant and then a clean meat farm, let's say, once you have all these steps implemented, and it will be much easier for us to implement all these diverse array of subspecies. And in that sense, we're definitely looking into that, looking at different cows or different avian species as well. And we definitely believe that will change as well the taste of the final product.
Yeah, I mean, you could have like a camel burger or an anteater burger or very unusual things that you would never normally have. Maybe they taste better. I don't know.
I agree. And also, it's if you think about some of these premium products, they are also very, you can find them maybe in very specific locations, or they are very typical for certain countries. And I think that having a platform like this can make a lot of these products more available worldwide and actually enable people to have this sensory experience, and to taste these really nice types of meats. So I think this will, the goal of diversifying the meats as we think about it nowadays, for me, it's one of the most interesting aspects of the whole program, because even the definition of meat per se, right? So I think that every time someone thinks about clean meat, the first perception is, oh, they're going to do like a steak. It's like they imagine like a steak coming out of a bioreactor, right? And I think that's not necessarily the case. I think that's definitely one line that we can pursue. But I think along the way, we will, again, by these unique combinations of cell types, like muscle cells, fat cells, as you mentioned before, we can even identify new flavors and textures and maybe just a new product that we never tried before. So I think that's also where our chefs can really play a very important role here. So I think that's one of the most interesting aspects of it.
Well, people already accuse frankfurters of being made of, 10 different things. So that'd probably be the easiest one. You can make a frankfurter out of anything and it, they would probably accept it as okay because, again, they already think they are made out of 10 different things.
Yeah. Yeah, the public, I mean, public perception is really a fascinating subject in a way. I think that, especially with clean meat, a lot of times people might be a little bit skeptical about this, but it's because, I don't know, people think of clean meat as coming out of the lab, but most of the technology that we are using is actually available in a lot of the food products that we are currently consuming. So a lot of this bioprocess, or a lot of this bioreactor talk that we mentioned, it's available and it's done nowadays. So we're not really doing anything that is so different. We are just like using it for a different application and assembling a lot of different technologies that are already out there for a very specific goal. So I think that once people also realize that, it will be much easier.
Can you use, once you get a certain line of cells, let's say from an Angus beef cow, can you use them over and over and over? Like bread makers will use the same yeast for 100 years. Can you use the same mother batch of cells and keep making as much as you want? Or do you have to get new cells continuously to make your meats?
You can definitely use the same ones. So I would divide the process of producing clean meat in two stages. So you have first your cell line establishment, let's say, that includes the step of creating your own master cell bank. So basically you have, once you identify some cells that work really well and that you have seen that have the ability to grow fast and that taste really good and can make the type of meat that you want, then you can just, bank those cells and do a cryopreservation, let's say. So you make sure that you can always come back to these cells later on in few years or even in more than a decade. So you just have to make sure that you bank enough number of cells for that to happen. And so yeah, I definitely, that's one of the advantages. You really identify your best cell types and you just make sure to keep them and preserve them. But also one thing that I believe is important here is once you identify, for instance, a certain subspecies or a certain cell type that is really favorable, that we know that works really well for our product, we can always come back and maybe do another biopsy and redo the process again. We have all the protocols implemented, so it will be easier for us to reproduce and do another banking. So we really believe that once we establish the platform, we'll be able to go back and redo it again with the same success.
What do you estimate the savings will be in terms of raising thousands of pigs or cattle, slaughtering them, etc., versus growing food in a lab, growing them in bioreactors? How much emissions, how much land, water, other resources? What's your estimate on the savings?
Yeah, I mean, it really depends on your levels of production. If you think about a clean meat farm that is on the scale of some of the biggest slaughterhouses in the U.S. or worldwide, we have definitely done some estimations for environmental impact, and we see that a decrease. Right now, I don't have exactly the numbers on top of my head, but I know that, and we also, we have those estimations, but we also don't really like to give exact numbers on that because we really know that might change a little bit once we get there. But in terms of CO2 emissions, in terms of water consumption, we know that it's expected to decrease for sure. But it depends on the scale that we're talking about. At the level that we are right now, the differences are even bigger for sure.
Okay. So, what are the barriers to mass producing, the clean meats and getting them into stores and in restaurants? And, how long do you think this is going to take? And what are the barriers, the major stumbling blocks to doing this?
Yeah. So, the first barrier in terms of the production itself is really bringing down the cost of the media. So, going back a little bit to what I was saying before, in terms of the composition of the media, these proteins that the cells need in order for them to grow, the goal, and I think most of the clean meat companies in the field are doing this at this moment, is really trying to find a replacement for fetal bovine serum as the main source, and finding something that really makes the cells grow as fast, but in a much more affordable way. So that's really, I think, fundamental. And once we get to the right formulation that is really cheap, then we're ready to move into these production facilities, into high volumes, and to produce it in a way that can be distributed worldwide. Until that stage, the goal will be for more smaller scale releases, maybe in few restaurants, and where we can start to have some feedback and to change and influence public perception. And then obviously, we're at the stage where we can do this, like I mentioned, the cell-based, then really is the integration of the technologies that are available nowadays to make something like production of muscle tissue at a very large scale. And for that, I think that something like 3D printing, for instance, can be really helpful. You can use the cells that come out of the bioreactors and assemble them into the type of structures that we want. So imagine something like a chicken breast or a steak. That requires for sure some sort of this more advanced technology. But again, for that you will need an automation and also an output that can fit the production levels that we need. So I think those two are the critical. First one, we're definitely on our way to get there pretty soon. The second one will be pursued later on.
So you said you have to use, it's called what, fetal bovine serum to grow the cells?
So that's in cell culture. So cell culture worldwide, not only in this field, but for instance, for pharmaceutical research. So typically uses fetal bovine serum as this supplement for to make the cells, to make the cells grow fast. So what we are doing here is replacing that fetal bovine. So we have to replace it with some other proteins, and in our case, we're using our plant-based proteins that we have collected in our discovery platform, and that we have used in the past, for instance, for some of our products, like our Just Egg or for Just Mayo. So we're using that not for the product itself in this case, but for the media formulation. And this can really bring down the cost of production and at the same time keep the functionality of the cells.
So what's the current cost estimate to produce a clean meat burger, like a 5-ounce burger, let's say, or per pound?
Yeah, so at that stage, I cannot reveal that yet, but I can say that our aim is to, for our release, to be at a level that is comparable to what you see currently in the grocery store. So that we know that it's the only way that people will accept this and that will consume our products and that will accept clean meat in general. We know it has to be affordable. It has to taste good, and if we achieve that, then we're really optimistic that people will accept it. But in terms of costs, yeah, right now we don't really give an estimation on that.
You think it's going to be quite a while before you can get the cost down, or you feel like you're close?
We feel that we're close for sure. So we are aiming for our first commercial release by the end of the year. So obviously when we think about something like this, it's because we're tackling that issue. It's just we don't really want to dive into much details on that on those numbers yet. And I'm just a scientist, so I'm not the guy that will make those decisions anyway. But I can tell you that definitely our media formulations are improving a lot and decreasing in the costs of production for sure.
Okay, very good. Well, what's a good way for listeners to find out more about what you're working on and your other products?
Yeah, so I think the listeners should visit our webpage, so justforall.com, and find us also in social media. So, and if anyone has any interest visiting or just getting more information, you can get also the email address in our webpage, and just get more information on our mission and yeah.
Okay. Well, very good. Well, I appreciate you coming on the podcast, and I'm looking forward to your anteater burger or your camel burger in the next few years, hopefully.
Thank you so much. Thanks for having me.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.